Hello everybody, my name is Zen Okami here with Essence of Zen. Today we're going to bring you a new Python tutorial, and I'm sorry about my absence. I've uploaded a video already explaining where I've been, what I've been up to. The new computer is now finished, and I am actually here to make this tutorial for one of our viewers, and I'm not sure this video is going to make it out in time, so I'm going to see if I can actually take care of that. I've already made the programs. I'm actually now recording the aftermath. So let me actually go in and show you. And we won't have any type of intro for the video because I have to recreate those sources and resources rather, and make some new animations and all that jazz. But anyway, I'm gonna open two versions. So today the video is going to be more about Python and adding binary numbers. So there's a really easy way to do it and a really more complex type of way. Decimal to bit. Nope. I had the file somewhere. Nope. Programming Python 3.4, adding binary. So we have two. So we have the easy version, which is right here. It is already set out. So essentially, when adding binary, if you do not know, it is actually kind of like adding normal numbers. So in normal decimal format, that's things like 212 plus 101 Dalmatians or something. And when you basically, you start from your top. 2 plus 1 is 3. 1, 3. That's your number. Awesome. The same can be said for I was expecting something totally different to happen there. The same can be said for binary. So in binary, because you're only dealing with two numbers, which is zeros and ones, you basically, anytime you go past 1, you start over. Like when you have a 9, when you reach 9, you add 1, you start with the 0 and carry the 1. The same is with binary, but you just only do with numbers zeros and ones. So for instance, if we have the binary number 0, 1, 1, and 1, 0, 1, and we add these together, 1 plus 1 is 2, but because we're doing binary, we only deal with zeros and ones. So 1 plus 1 will actually be 0, carry the 1. 1 plus 0 is 1, but plus another 1 is 0, carry the 1. 1 plus 0 is 1, plus 1 is 0, carry the 1, bring down, and you have this new binary number. So when dealing with that with programming, you have to have an algorithm to do this. But luckily, if you're in a rush and you don't want to make the algorithm by hand, you can utilize Python's built-in functions that utilizes the integer and the binary functions, or built-in methods, whichever you want to call them. So for instance, what we have here, we have a variable called binary 1 and binary 2. It'll ask for user input, and user input a string of numbers, and then it'll actually take that and you create a new variable, or two new variables, decimal 1 and decimal 2, and it will make that string into a binary number. So yeah. And actually, I can't remember what the second integer was for. Oh yeah, base. So binary, you turning the 2 right here is the fact that it's binary, because binary has a base 2 of operations, zeros and ones, whereas decimal has a base of 10. But I digress. So the user inputs a string. The string gets turned into an actual integer of zeros and ones, and then we print them, and then we add them, and then we print the new sum. So let's go ahead and run it. Yes, yes, yes. So I'm gonna have in the um, uh, binary 101, excuse me, and I'm going to have the next one be 010. So we should have 111, and there you go. So it actually, I had to convert, not convert, but you see we print out our original number, which is decimal 1 and decimal 2. Well, it's not it's our number, our binary number turned into a decimal number, and then that decimal number gets added, and then we have our new decimal number, the 7, because 5 plus 2 is 7, and then we turn 7 into a binary number, that being 111. If you're curious about the 0B, that just lets you know it's a I believe unsigned binary, and the B stands for binary. I do believe that's what the beginning 0 is for. Forgive me if I'm wrong, or correct me in the comments below if I'm wrong and you want to correct me. So that's the easiest way to do it. Another more convoluted way is this right here. Yeah. So don't mind the functions just yet. I don't even know where I want to start it. I mean, we're going to eventually code this from the ground up. I just want to let you guys see this now in case you don't want to watch the entire video fully through. So essentially what I decided to do with the algorithm that I wanted to build for this particular program, while keeping it sort of kind of as simple as possible without going into so many functions and creating a Python package and then calling those into play and etc. I'm going to go ahead and show you what it essentially is. So my idea was to simply have a user input 2 binary numbers. So for instance, first one will be 0, let's kind of look a Q, 0, 1, 0, 1, and the second one will be something like 1, 0, 0, 1. Okay, I wanted these to be put into an array, or in Python they're called lists. So those get turned into a list of individual elements. So 0, 1, 0, 1. And because most binary numbers are arranged from a byte, so 8 binary bits, or binary numbers, which are bits, we'll eventually have to make these into an array with 8 elements in them. And this one becomes 1, 0, 0, 1, and those are brackets, by the way. Sorry if it's kind of weird. So you always want to start at your far right, and so I want to have like this one be add this to this one, and then carry the one, etc. To do that, you must always know your array's elements location. So to make sure that if, like for instance, if I would have had the first number be 0, 1, 0, 1, 1 compared to just 1, 0, 0, 1, there'd be a miscommunication for the program to say, oh, I don't know where the final element for this array compared to this array, because if I say array 1 at index 2 add to array 2 index at 2, they're gonna have the different placements. If you don't understand what I'm saying, I'm saying more like this. So you have 0, 1, 0, 1, 1, and you want this to happen. You want to have them lined up like this. But if I don't have them all having the equal amount of elements, it's actually going to end up looking like this. Can I actually move that? Yes, I can. It's actually going to line up like this. So this one is going to go to this one, this 0 to that 0, that 1 to that 0, and this 0 to that 1. And we're going to have this 1 over in this first array left over kind of confused, like I didn't do anything. And you're going to have your entire, addition thrown off. So to fix that, you basically want to have the program look at this array and say, is it made of 8 elements? If not, I want to add how many elements needed to get this full array to have 8 elements for both of them. So for instance, if I have, this number right here, these two will actually end up becoming 0, 0, 0, 0, 0, 1, 0, 1, 4, 4, yeah, and etc. This is starting to get a little ugly, so I'm gonna actually close that out. And it'll get turned to 8 elements, and then you can actually add based on the locations. So now we're at our 10-minute marker, or our 11-minute marker here. I'm gonna scroll this up in case someone wants to stop and actually just look at the code and try to decode it, by themselves. Other than that, I'm actually going to retype this, or recreate this rather, in the video. So if you're finished, thank you for watching. Like, subscribe, leave a comment asking questions or suggestions, things you want to see done. And if you're sticking around for the next half, let's jump into it. So we're gonna go ahead and move this on over here. Yep. Anybody watch, like, anyone's a 90s kid? You remember Zaboomafoo? There's a new cartoon now called the Wildcat Brothers where it's animated and it's the two brothers, but whatever. So we're gonna create a new program. Alrighty, and we're gonna just call this the adding binary dash yay. We're gonna save this. Oh, and keep in mind, there is a better way to organize the code that I showed you previously, and that I'm gonna show you here. I just kind of wanted to make it easy to follow, so to say. Adding binary video. Where was I? Oh, I wanted to make the program easy to follow from the top down, so you can actually look and read. There's better loops you can use, better functions, built-in functions you can use, like in the easy one I showed you. But for practice purposes and getting used to figuring out algorithms and etc., I'm going to show you the best way that I feel that was intended to use. So we're going to go ahead and actually have our main program. And in the one that I showed you, I didn't actually have this to be a main program, but we're going to create our function def main. Okay, and in this function we're going to have 2 variables, our user binary. That's 1. We're going to do space there, and user binary 2 equals. So we're going to have our we're going to have the user input the variables. So input binary number, and we're gonna copy this because it's for both of them. Well, for each individually. Maybe I should do first, second. Alrighty. I'm gonna add a print line as usual. So essentially what this does, this is getting the input from user. And I'm not gonna user-proof it now because I hate trying to think about the try-catch and the conditions to make sure that the user inputs correct and valid data. So just bear in mind, this is just for learning. This isn't actual for use. You can use it and you can build upon it all you want. We're gonna make them into an array. And just to show you that this is working, whoops. Just to show you that is working. Of course. Main. And binary first should be first binary number, whatever. 1 0 0 1 and 0 1 0 1. and see they print out. So it's working so far. Now we're going to make them into an array. So that's basically just doing like you're turning into a list. So we're gonna go ahead and do user binary array. Well, let's just turn to, because I think I did this in the original one. We just use the actual same variable and we just overwrite it. So this will be list user binary 1, and then user binary 2 equals list user binary 2. And then we're going to print that and print this just to show you that it's working. 001, 0101. And so now we have our list, right? Awesome. So next thing, remember I told you that we want to make sure that they're always checked into to make sure the length of the array itself is nice and dandy. Well, we can do that here. I had to open it up and actually see. Yeah. So you're gonna make sure binary array is set to, excuse me for one moment. My dog wanted to get out. All right. Make sure the binary array is set to 8 elements. To do this, it essentially, you make a loop that checks the length of the array, and then depending on its size, it'll jump into the 0 index and insert zeros in front of it. So if you have a 4 length binary number, you're just gonna add 4 zeros in front of that. So to do that, we'll basically say while length of user binary 1 is less than 8. We're gonna basically insert from user I just copied it. Insert at index 0. Wait, this is the right function, isn't it? Hope this works. Usually you get a little attack message saying what it does and whatnot. At index 0, insert a 0. And that should do that. And then we'll do the same for user binary 2, less than 8. User binary 2. Oh, I forgot. Insert. Insert at index 0, zeros. Alright, and then we're going to print us a line, and then print our user binary 1 and print user binary 2. Alright, so let's do 1001 and 1111, and now this should be turned to a long length of 4 zeros in front of both of those. Awesome. So now we have our 8-bit long binary number. So it is officially a byte. So now we have our 1, 2, 3, 4, 5, 6, 7, 8, and see how they're nice and lined up, like very nice and neatly. Sweet. So from here, we already checked them. We need to add them together now. And to do that, we have to add the arrays. Now, I didn't want to do the adding array part inside the main code, because I feel that if you're this far into doing algorithms, you'll know how to do functions. So I'm gonna go ahead and actually make our a new function, like I could have done previously with the changing the binary lengths to 8 bits. But you know, whatever. This is a little more annoying to deal with though. So we're gonna have a function called add arrays. You're gonna have array 1 and array 2, and I'm pretty sure if you're watching this video, you may take programming classes or, you know, read tutorials online and etc. It is always a wonderful idea to make sure your functions have a name that you can tell what they're doing. So when you see a function that says add arrays, you'll know, generally speaking, it should add arrays. So where was I? So when we add arrays, do you remember how when you have 2 1s, like 1 plus 1, it go back to 0, and you have you carry the 1 to the next spot? It's kind of like moving. Well, actually, you are moving bits. So if you ever did like digital logic, and I'll show. I think I did a video previously like that before. When you create a binary, a binary controller where you move bits around a lot, you always have a carrier. So we're going to actually create a variable called our carry variable. And this is basically when we have 1 plus 1 equals 0, carry the 1, that 1 gets thrown into the carry. So let's see, for carrying extra. Or after addition. I don't know how to explain that in terms of, I spelled that right? Yes, I did, I think. I don't know how to explain that in terms of writing. Just let's see. Now we go, because the list is a list of binary numbers, but they're strings. You see those I guess apostrophes, because they're not quotations, they're single quotation apostrophes. That means they're each, well, they're really a character, a char, but we'll just say it's a list of strings. So now we got to convert those strings into numbers so we can actually add them correctly. So from here, we're going to basically do a new variable called int array 1 and int array 2 equal. And basically what this will do is it'll turn, we're going to make a code here that it's like a for loop, and it'll turn every element inside the list into an integer. So to do that, we're going to create, well, it'll make a new array with a loop in it that turns every element into an integer and add them to this new array. So we created an empty array, or an empty list, whichever you want to call them. And we're going to have int at index for index in array 1. And if you know about loops, it's kind of like saying I for I in whatever list. So, well, it's more like saying for I in whatever, but if you program in C++, or in Java, you'll know what this is kind of reminds you of. But we've initialized, though we don't need to because it's Python, the variable index, but we initialize it so it makes sure that it knows it's an integer and not a char or a string. So then we have that done. We're going to do the same thing for this one. So int index. I could have just copied this, but I didn't want to. And array 2. Don't you boom at me. And now we're gonna have a variable like length, for length of array. We're gonna put 7 because although there are 8 elements in our array, we all know that array's first element starts at 0. So we have 0 through 7, which are 8 numbers. So we're just gonna have it at 7. And we're gonna create a empty array. Well, excuse me. When I say empty, I mean a default zeroed out array called final array equals nothing but 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Oh. 4, 4. Yep. And see, now here's an annoying thing. So we're going to basically do all the adding now. So now that our final array, well, we have our two arrays that are now made up of actual integers. You know what, let me actually show you this just in case. Print int array 1, print int array 2. And we go back down to main. And what we're going to do is print that. And then we're going to call the function add arrays. That's why I didn't want to copy over. Oh, no. And booyah. Add arrays, user binary 1 and user binary 2. That should work. So do and do. Righteous. Okay, so we call that function and it actually printed out our new integer arrays. So as you can see, the zeros no longer have the apostrophes on them, so they're no longer clarified as classified as a char or a string. They are now integers. And no, you don't need to use floats if anyone thought about using floats, because binary, you know, they're just zeros and ones. They're not 0 point anything. They're always simply zeros and ones, unless you want to do some type of also bit conversions like we did in our previous tutorials. Then you can probably use floats in some areas, but I wouldn't advise printing them out as floats. But anyway, so yeah, it's working so far. Let's comment these back out. This is gonna be a long video. I didn't expect it to be this long. Okay, so we now have that working. Now, this is also the weird kind of funny part, because this is kind of how I did it. Let me bring Paint back up actually. So at this point, we're gonna essentially add them together. Matter of fact, let me go ahead and actually add the adding code. And when you see like why I'm kind of flabbergasted at how to what the heck? I hate Python's indentation sometimes. Yeah. So where was I? You're gonna see why I'm kind of flabbergasted for the part after this. So we're basically gonna add all the numbers together, and yeah, I know what you're thinking. I know exactly what you're thinking. Well, some of you may be thinking, but just bear with me. So we're gonna have our final array at index length. You know what? Let's rename this to position. I mean, I can use index too, but I don't like using the variable word index for an actual variable. I use index for in place of I, but you know, whatever, because I like to break the norms. So final array at the index of position, because position is currently 7, so we're starting at the end of our list. We're going to add int array 1 at position plus int array 2 at position. And then we're going to decrement the position. So for many of you astute people, you'll and I said astute, not stupid, astute viewers, you'll probably realize that I just added numbers that went past our brackets for binaries. So in other words, binaries are just zeros and ones. But if I used 1, 0, 0, 1 and 0, 1, 0, 1, and I just added them based on their position. So you have your 1, 0, 0, 1 and your 0, 1, 0, 1, and basically I just created a program that searches for the last index, and it adds, you know, both arrays last index and then moves both of them to the left. So it goes final index 1 plus 1, 2, next index 0 plus 0, 0, next index 0 plus 1, 1, next index 1 plus 0, 1, and it does that. Now, everything is pretty much fine except for there's a 2. You know, binary do not do 2. You know, in the mighty words of Bender from Futurama, you know, I had a nightmare, all these zeros and ones, and I think I saw a 2. To solve that problem, we have to make our own algorithm that converts this number into a complete and actual binary number. I'm pretty sure there's a better way to do this, but I went out and did a long and very conditional statement branched out version of this, and essentially what I came up with was we're gonna now have this new array that has a mix of ones or zeros, ones, twos, and possible threes. If you're wondering like how could there be a possible 3, for instance, in this case we had a 1 and a 1, and that gave us 2. Now we know for a fact if we was going to do a carrier, this would be a 1 and we'd carry a 1 and then so and so. But imagine if we had 1 0 1 1 with 0 0 1 1, I think. So now we're gonna have a 2, which actually should, that just scared me. Smoothie Kings, Amazon, and yeah. Let me actually snooze my notifications for a while. Hi, for an hour. Thank you. I'm still getting used to Windows 8, by the way. So we know that this should actually be a 1. And then we're going to carry the 1. And in this case, it would still add up together and make a 3. So we have, you know, basically some possibilities that we'll either have 0, 1, 2, or 3 in our mixed final array here. Alright? To solve that problem, we have to convert this into the real binary number while making conditional statements for these. I'm pretty sure that we'll probably never really ever have a 3 pop up into place at the start. Like, it should never actually happen. And there's ways to work around that. But for the easiest way, in my knowledge, to do, you create a set of conditions, and you can do what do they call it? I know in Java they're called cases, where you can have you know, case 0, then case 1, based on independent of a variable, but whatever. So when we have a 3, it's gonna convert that 3 into a 1, and then carry will equal 1. If there's a 2 will become a 0 with a carry of 1. If the number is a 1, it'll be moved into 1 with no carry. And then if this 0 is going to be a 0 with no carry. If that's easy to understand. So essentially speaking, like 1 plus 1 is a 2. Okay, 2 get transformed into a 0, and then we add a carry 1. Then 1 plus 1 plus 1 because of the carry, because we're going to add the carry in as well, is 3. So now we have a 3 which gets transformed into a 1, and then carry gets turned back into a 1. So then we're going to add a 1 here. And then, so this is going to be, whoops. Back when I said 1 plus 1 should be a 1, 1 plus 1 should be a 0, my bad. So then, so this becomes a 1, we carry the 1, 0 plus 0 is 0, plus 1, etc. And then 1 plus 0 is 1. So now we have to do that into the form of code. Excuse me. To do that, first we'll go ahead and make our reminder. 3 equals 1 C1. 2 equals 0. Did I do that right? Yeah. 0 with a carry 1. 1 equals 1 carry 0, and 0 equals 0 with a carry 0. This is basically our little code to keep in mind. I guess we will have to actually make a new position variable. Go back to 7. And then we'll create our actual loop. So while our position is greater than -1, kind of like how we did up there, our final array at position let's make sure we spell position right. Final array at position will equal final array at position plus carry. I think I did that right. Wait, where is my carry? Oh, it's way up there. Okay, yeah. So now we have to make our conditional statements. So if our final array at position, should I spell that right? Because I am a horrible speller. Position equals 3, and I'm going to use this variable name a lot, so let's copy that. For instance, like that will equal 1, carry will equal 1, and then we'll actually decrement our position. Holy crap. Sorry about that. If you saw that earlier and that was bugging you, I apologize. I know how weird it can be or how frustrating it can be when you have someone who's recording and they do that and they don't catch it and you're like, oh, you idiot. So we're just gonna move on over. Position 1, well, -1. Elif. I do this. 2. Do this equal 0, but our carry still equals 1, and our position is still decrement 1. Elif equals 1. Then our final position right here will equal 1, but our carry will equal 0, and our position we decrement 1. Elif equals 0. Final position equals 0. No carry, and position minus equals 1. Else print something went wrong, Captain. That's what I was thinking about, Captain. Alright, and that should actually be the rest of the program. So then we're just gonna have to return the final array, I think. So when we have something like this, we'll have final array sum equal that print final array. Let's give it a shot. So 1001, 10, no, 0 1 0 1. So we should have let's make it easy. So we should have all straight ones. Oh no, we got a problem. Line 13 and add arrays while time. Oh, whoops. Position. My mind is still caught on my old program. I use different variable names. Final array is not defined. Line 69. Oops. Guys, I'm sleepy. Sorry. 1 0 1 0 0. And booyah, there we go. Now, that's basically the entire program. If you don't want the final outcome to be an array like this, what I would suggest doing is I like to have at least the array version to still be shown somewhere. So what I would end up doing is final array. Print that there. What you can actually do, how do you concatenate it again? I think it's called join. A equals 1 2 3 4. A dot join. No. It's oh, okay, yeah. So it's A equals join A. Wait, no, expected string is. That's right. There gotta be strings. Strings. Yeah. Of course they do. A. Now they're all strings, and then we'll just do A equals dot join A. Booyah. Okay, there you go. So so this should print out as array. Oh, we're pretty much done with the video. I'm just showing this for people who wants to have the final outcome be a full string and not the concatenated or the separated elements in an array. So what you can do is now we're gonna turn final array into a string index for index in final array, and then we're going to have final array equal bam bam, thank you ma'am, who's gonna love it, your family am. That's a Malcolm in the Middle reference for any other 90s kid. Final array, yada yada yada. Let's give it a shot. 1001 1010. Sweet. Yep, 1011. Wait. Yeah, excuse me. 10011 because the final one is add together. So that's basically the program within a nutshell. As we go almost an hour long, I'm gonna edit the crap out of this video to make it shorter. Yeah, we uploaded this to our GitHub account, Essence of Zenic, you know, whatever GitHub is. Hope you enjoyed the video. If it helped you out, please leave a like. If you have any questions, add them to the comment section below. We will be I will update this program as time goes on because I actually enjoyed the methods that I used, and I want to see if I can actually cut down on a lot of things and get things looking a lot neater. And I'm also working on my own Python package, so it's like a module. It'll help me with my own programming projects later on. But feel free to fork it, copy it, and you know, edit it, and you know, use it as a base to learn for yourselves. Like I said, there are many better ways you can do this. Feel free to try, make a challenge to yourself. See if you can cut down the amount of code in this project to get it running faster, better, look neater, look more professional, and etc. So yeah, that's pretty much it for this video. I will try to edit it so it's not, you know, about an hour long. But yeah. Thank you all for watching. Subscribe if you want to see more. If you have any other things you would like to see that are within my programming abilities, request them below. I have I actually have made one project that I'm actually quite proud of. So can I show you Python temperature converter? Is it gonna work? Is it gonna work? Please let it work. Yes, it worked. I'm not sure if I actually put this in a video before though. I'm totally not 100% sure. But anyway, this is a program that I was working on. I was learning how to do a GUI, and I made one. So yeah. So depending on what you have, it can actually convert anything into the other. So you have your Fahrenheit to Celsius and your Celsius to Fahrenheit. So for instance, 32 degrees Fahrenheit is, whoops. 32 degrees Fahrenheit is actually 0 degrees in Celsius, and 0 degrees in Celsius is 32 degrees in Fahrenheit. Yeah, and if you quit, it quits. But yeah, if I will check and make sure if I haven't done a video. Like I said, I lost a lot of stuff when the previous system crashed, but whatever. So I forgot what I was gonna say. I've already said, you know, to like, subscribe, comment. I guess I'll just see you in the next video, guys. We're still working on a lot of things. Like I told you, I have to redo the resources for the intros and create the presets for music and all that wonderful, wonderful, wonderful jazz. So until the next video, guys, I'm gonna catch you in the next one. Take care.